Hello everyone, my name is Harish Kumar. Today we are going to learn the very first chapter of class 10, that is real number. Before the very first topic of this chapter, real number, is fundamental theorem of arithmetic. Before I go for this class 10 topic, that is fundamental theorem of arithmetic, I just wanted to let you recall the basic things which is required to understand the fundamental theorem of arithmetic. Like we know that, so far we know that what is prime number. What is prime number? So any number which have only two factors, one and the number itself is known as prime number. For example, 2, 3, 5, 7, these are all known as prime numbers. Okay, 13, 17, because 2 has only two factor, 1 and the number itself. 3 we can write as a 1 and 3 only. 5 has only two factor, 1 and 5 itself. Every number which has only two factor is known as prime number. Okay, so one more thing is required, a composite number. So composite number is the complement of prime number. So definition goes like any number which has more than two factor is known as composite number. For example, 4 can be written as 4 has a factor like 2, 2, 2, 1. When we give prime factorization of 4, we get 4 can be written as 4, 2 into 2. So 4 has a factor, एक तो 1 and 2, एक 2, we can write 4 as a 4 into 1. Okay, so here other than 4 and the 1 which is required for the prime number, 4 has a one more factor, that is 2. So 4 is a composite number, and let me tell you, 4 is the smallest composite number. Okay, let me give you some more example. Like 18. Why 18 is a composite number? So 18 has a factor 1, 2, 1 to 9 and the 18 itself. Okay, 6 3s are, that is all also. So 6 is also there, 6 and 3. So these are the factors of 18. 1, 2, 3, 6, 9, 18. So here we can clearly see that 18 has a more than 2 factor, that is 1, 2, 3, 6, 9, 18. So therefore it is called composite number. Talking about 24, 24 is also composite number because it has a factor 1, 4, 6, 8, 3 is also there, 12, 2 is there. So these are the factors of 24. So 24 also having a more than 2 factor, that is therefore it is called composite number. Now talking about co-prime. So co-prime is basically, we, as you all are knowing that till 9th we learned about co-prime is a pair of number whose HCF is 1 for any two number A and B. कोप्राइम एक पेयर होता है नंबर का, ऐसे पेयर जिसका HCF 1 हो वो क्या कहलाते हैं? कोप्राइम. So okay, so in order to understand the fundamental theorem of arithmetic, we have already learned up to class 9 that what is prime number, composite number and co-prime number. So let's just start with the first topic of the class 10 real number, that is fundamental theorem of arithmetic. These are the basic things that you should know. I have given you the small glimpses about that. Now we shall focus on the fundamental theorem of arithmetic. What is the statement for the fundamental theorem of arithmetic and what is their use? We will just see in the next few minutes. So the statement says that every composite number can be expressed as the product of their prime factor except the order they appears. For example, every composite number. Okay, suppose prime factor of 20 is, the smallest prime number is, which can divide is 2, so here 10, again 2, so here 5, again 5, so here 1. So 20 can be written as 2 into 2 into 5. Okay, but we can write this also as a 2 into 5 into 2 or 5 into 2 into 2. Here, now try to understand the statement that every composite number can be expressed as the product of their prime factors. So here 20 is a composite number. Why? Because it has factor more than 2. 1, 2, 5 and 20 itself. Okay, so 20 can be written as a prime factor, like 20 has a prime factor 2 into 2 into 5. This is a unique, but this can be presented in a different order. Order means here 2 into 2 into 5 can be written as 2 into 5 into 2 or 5 into 2 into 2. So order is different, but we have represented composite number, that is 20, as a product of their prime number. Okay, so this is the meaning of, this is the statement of fundamental theorem of arithmetic, and this is the example. Now the question arises that what is the use of fundamental theorem of arithmetic? So प्यारे बच्चों, we use this fundamental theorem of arithmetic to find the LCM and HCF of any two or more than two number. Okay, so let us just try to understand what is the HCF and what is the LCM. So HCF is nothing but it is the highest common factor. It is the highest common factor of two number is known as HCF, or we also call it as a GCD, greatest common divisor. Both are the same thing. I will give some example. In NCERT it is written that HCF of a number is the highest common, is the greatest number which is common to given number. What is the LCM? It is the product of greatest power of a prime number. Greatest power of a prime numbers. Suppose बच्चों, suppose we are asked to find SCF and LCM of 6 and 20. Okay, we have one question. To understand this, I have taken one example. Suppose we have asked to find the SCF and LCM of 6 and 20. So prime factors of 6 is 2, 3, 3, 1. So 6 can be written as 2 into 3. Okay. What is 20? 20 can be written as here 2 into 2 into 5. So talking about the SCF of 6 and 20. Here 2 is the greatest number which is common to both, as you can see here. 2 is the greatest number which is common to both. So SCF of 6 and 20 is 2. Talking about LCM of 6 and 20. So as the statement says that LCM is the product of the greatest power of the prime number. So here in a number 6 and 20, the prime number are 2, 3 and 5, and product, it is asked for LCM says that product of greatest power of prime number. So here the power of 2 sorry here can I write 20 as a 2 to the power 2 into 5. So one by one we will take the prime factor 2, 3 and 5. So 2 has the greatest power 2, so I am writing 2 to the power 2. Here 3 has the greatest power just 3, so I have written just 3. 5 has the greatest power here is just 1. Okay, so 4 into 3 into 5, that is 12 into 5, that is 16. So LCM of 6 and 20 is 2, whereas LCM of 6 and 20 is 16. So this is the statement and the few examples of fundamental theorem of arithmetics. I have given you the statement. I have given you some examples related to how to find the SCF and LCM of two number. Okay. In continuation to this, one more thing I just wanted to tell you. One formula is there. Suppose for a two number A and B, we have some formula that is for any two number A and B, the product of the number is equal to the product of SCF of that number to the LCM of that number. Positive integers. Okay, that need to be positive integer. Let me repeat it for better impact. For any two positive integers A and B, their product is always equal to their product of the SCF and LCM. The product of two positive integers is always equal to the SCF of their product of the SCF and the LCM of the same number. Let us see some example, like let's just verify this. Suppose as we have just find out the SCF of 6 and 20 is 2 and LCM of 6 and 20 is 16. Let's just verify this formula for this. So A into B, that is 6 into 20, that should be equals to SCF, that is 2 into 60. Okay, so it is 120, 260 is again 120. Hence, RHS is equals to LHS. Hence verified. Hence verified. You will get more question to solve in your NCERT book. So you can use this for the any two positive integers. This formula is there. You can verify this. This question may ask you in a different way, in a 4 different possible way. Suppose examiner will give you A and B. They will also provide you SCF, but they will ask you to find its LCM. So by interchanging this value to there, you can find the LCM here. Or sometime examiner say you to find the one missing number. Suppose A is missing, B is given, SF is given, LCM is given. So how to find the value of A? So we will just transpose B to here. So in this case, we have 4 possibility, either A, B, SCF or LCM. So examiner may ask you in this 4 different possible way. Always remember bachcho, that this formula is only applicable for the any two positive integers. Suppose we are given more than 2. Suppose we are given 3 numbers. So what is the formula for that? Let me tell you, like for 3 numbers. For 3 positive integer A, B, C. Here we have formula that LCM of A, B, C is equals to A into B into C to the SCF of A, B, C divided by SCF of AB into SCF of BC into SCF of CA. Or one more formula is there, that SCF of ABC is equals to A into B into C whole bracket LCM of ABC divided by LCM of AB into LCM of BC into LCM of CA. So in the fundamental theorem of arithmetic, to extension to that, we have 3 formula. For 2 positive integers is this, and for 3 positive integers is this. You will hardly get questions from here, but most of the NCERT questions are focused to this formula. So practice more questions from book only. Okay. Till class 9, we know that what is natural number, what is whole number, what is integer, rational, irrational number. These are the basic things we should know about the number system. So let's just start with the natural numbers. So all the counting numbers are known as natural numbers. It starts from 1, 2, 3, dash, dash, dash till infinite. What is whole number? So the number 0 with the natural number is known as whole number. 0 and natural number is known as whole number. So example 0, 1, 2, dash, dash, dash till infinity. These are known as whole number. What is integer? So we know that from class 8 that integer is a set of all the negative numbers, 0 and set of all the positive numbers is known as integers. Here noteworthy point is that every natural number is a whole number, and every whole number is a part of integers. Whole number includes 0 and set of all positive numbers, this whole number. But when we include the set of all negative numbers with the 0 and the set of all positive numbers, it's called integers. Now talking about the rational numbers. So rational numbers, we have definition for the rational number is that let P and Q be 2 integers, then any number which can be written in the form of p by q, where q is not equals to 0, is known as rational number. For example, 1 by 2 minus 1 by 3 minus 3 by 6 minus 7 by minus 11 etc. Few special symbols are there in mathematics such as pi and exponential. These are also known as rational number. Now I am going to tell you how to identify that whether any number which is given in a decimal form, in a decimal expression, is a rational number or irrational number. So here we have condition like for any real number in a decimal expression, if the number is written in the form of, we have two cases, terminating and non-terminating. So suppose we have 3.5. Here 3.5 is what? Terminating, because after 3.5 it is not going anywhere, so it will call as a terminating. I have written 2, 3, 5. These are all numbers. So here what I want to say that if the decimal expression of any number is terminating, then it is always called rational number. So here 3.5, 1.5, 2.5 or any decimal which is terminating is known as rational number. Here I said that like a number, all the number 2, 3, 5, 6, they are also known as a rational number. But for the second case, suppose the decimal expression of any number is non-terminating. In that case, we come up with the another sub-classification like non-terminating but repeating, non-terminating but non-terminating, non-repeating. So any decimal expression which is non-terminating but repeating, like I have taken one example like 2 by 3, we can write as 0.666. Here the digit 6 is continuously repeating itself, but it is non-terminating, it is going endlessly. So this is condition of what? Rational number. This is the condition of rational number. One more example like 1 by 3 can be written as 0.333 dash dash dash. So here the digit 3 is repeating itself continuously and it is going endlessly. So it is a case of non-terminating but repeating. If the decimal expression of any number is non-terminating but repeating, then it is known as rational number. Okay. Now talking about a few things like what if the case arises for the non-terminating but non-repeating. Suppose I have written pi. Pi has a value 3.14. No, it has one more few more digits attached to it after decimal. Like when we write the value of pi, it's not just 3.14. It is expanded to 3.14159265 dash dash dash. Here we can see that the value of pi after decimal, they are like continuously endlessly going, so they are non-repeating and they are non-terminating. So as I said, like pi is a rational number, but the value of pi is irrational number. So wherever the cases arises for a non-terminating and non-repeating, they are always irrational numbers. Always remember bachcho that all the decimal expansion which is non-terminating and non-repeating is known as irrational number. Let us take one more example, like the value of root 2 is not just 1.41. It is fully written as value of root 2 is 1.4142135 dash dash dash. Like here no digit is repeating and they are going continuously. So they are the case of non-repeating and non-terminating. So likewise any number, suppose root of prime number, all the root of prime number is known as irrational number. All the roots of prime number is known as known as irrational number. Like we said, like a root 3, root 5, root 7, root 11, root 13. We can expand it to infinitely. Okay. So this is the way. Now we will see how to prove that these are what decimal expression. No? Now we will see the theoretical part to prove that any number can be root of prime number can be proved to be irrational number. So by the method of contradiction we shall see. Okay. So let's erase this. We will see the theoretical proof of any irrational number. Suppose we are asked to prove that root 2, root 3, root 5, root 7, these are all irrational numbers. Then now we shall learn how to prove that for the irrational number. Suppose we have question to prove root 2 is a irrational number. Okay. To prove this theorem, we have to use one lemma. What is the lemma? So lemma says that if p square is divisible by any number a, okay, if p square is divisible by any number a, then this implies that p is also divisible by that particular number a. And let us see some example. Like here, 16 is divisible by 2. Of course, 8 2s are 16. Can I write that? Suppose p square is 16. So what is the value of p? It will be 4. So 4 is divisible by 2 or not? Yes, it is divisible by 2. So lemma says that if p square is divisible by any number a, then p is also divisible by a. Like we have seen one example. I can give you one more example. Suppose 36. 36 is divisible by 6. Okay. So what is the root of 36? It's just 6. 6 is divisible by 6. Every number, always remember that 1 and the number itself is always the multiple of themselves. Like when we multiply 6 into 1, we get 6 now. So 6 is ultimately divided by 6 with 1. So if 36 is divisible by 6, then obviously 6 is divisible by 6. So now we will use this lemma to prove this theorem, that is root 2 is an irrational number by the method of contradiction. So I will erase this part. Okay. So one by one we are seeing each steps. Suppose let by the method of contradiction, let assume that root 2 is not irrational number. We have assumed that root 2 is not irrational number, then automatically it implies that, as we have talked, that rational number and irrational number are complement to each other. So if root 2 is not irrational number, then obviously it is rational number. This implies that root 2 is a rational number. These are the things we have supposed. So this implies that root 2 can be written in the form of p by q, where q is not equals to 0 and p and q are co-prime number. So what is a co-prime number? We know that from our basic knowledge up to class 9, that co-prime number is the pair of number whose SCF is 1. Okay. So here, squaring on both sides, we get that root 2 square p by q whole square. This is what? 2p square upon q square. This implies that we can write p square as 2 into q square. Okay, here p square is divisible by 2. So by using the lemma that I just taught you, that if p square is divisible by 2, then this implies that p is also divisible by 2. Okay, let's just take this equation as equation number 1. Okay, and this as equation number 2. I will tell you why I have taken this as an equation. I will tell you later. Now, if p is divisible by 2, so there must exist a number, say m, with which we can write as p is 2 into m. I said that if p is divisible by 2, then there must exist another number, say m. I have assumed it that it is any number m. So I can write that p is a multiple of 2 using m. Here, when we square on both sides, here squaring both sides, we get p square is 2m whole square, which is 2 to the power 2, m to the power m square. No. So here I written p square as 2 square is 4 and m square. Now just take it as a equation number 3. Okay. Now we will equate equation number 1 and equation number 3. So by equating equation 1 and 3, we get what we get here. It's just 2q square. 2q square will be equals to 4m square. Here we can take 2 into 2m square. So this 2 and this 2 will get cancelled out. What is remaining is here q square is equals to 2m square. Here we can say that q square is divisible by 2, and by using the same lemma that we have just studied, we can say that if q square is divisible by 2, then we can say that q is also divisible by 2. Let us take as an equation number 4. Here, see bacho, equation number 2nd and equation number 4 says that p is divisible by 2, and equation number 4 says that q is divisible by 2. When we combine that, we say that p and q are divisible by 2. This is that the HCF of p and q is 2, isn't it? But we have assumed that root 2, which is equals to p by q, where p and q are co-prime, like their HCF should be 1. But we have come to the conclusion that here p and q are divisible by 2, and their highest common factor when we find it is 2. So here we have felt some contradiction. So but we have assumed p and q to be co-prime, which contradict or oppose our assumption. Hence our assumption was wrong, and thus root 2 is a irrational number. Okay. Yes. Here it is the proof of that root 2 is a irrational number. Let me repeat it for the better impact. Here we have used the method of contradiction. We consider that root 2 is a rational number. Suppose, what is the method of contradiction? Suppose we want to prove that it is a daytime. Okay. So in order to prove that it is a daytime, we will use the method of contradiction, which says that we need to prove some fact which says that it is a night time. It is not a night time. So we all know that there is only two things. Either it may be a state of day or night. So in order to prove this present moment is a daytime, we need to give some facts that it is not the night time. Kind of things we use for the method of contradiction. So in order to prove that root 2 is not a rational number, we have taken assumed it that root 2 is a rational number. Then by the definition of rational number, we have considered equated that root 2 is a p by q, can be written in the form of p by q, where q is not equal to 0, and p and q are generally co-prime, so their SCF should be 1. Now we square this equation to both sides. So when we square, we get that 2 square of root 2 is just 2, p square upon q square. When we transpose these things here, we will get that p square is 2 into q square. This shows that p square is a multiple of 2, because somewhere we are multiplying this term to 2 to get this. So ultimately p square is divisible by 2. And now for this line, we have taken the lemma that I have taught you in the start of the video, that if p square is divisible by 2, then automatically p is also divisible by 2. So we have written this statement. We have given equation 1 to this and equation number 2 to this. Now, if you are saying that p is divisible by 2, then there must exist another number, say n, which is for which the p is the multiple of 2. So we have written p is equals to 2 into n. Again, squaring on both sides, we will get that p square is 4m square, which we have taken as a equation number 3rd. Now equating equation number 1 and equation number 3rd. So since in this both equation right hand side is equal, left hand side is equal, so this will be equals to 2q square will be equals to 4m square. So here I have written 2q square is equals to 4m square. In this, take out this 4 common and cancel out with them. You will get q square is equals to 2m square. This shows that q square is divisible by 2. So this implies that q is divisible by 2 by lemma. Now from equation number 4 and equation number 2, we come to conclusion that p and q are divisible by 2. That means their highest common factor is 2, not 1. But we have considered to be it is a co-prime, which shows the contradiction that our assumption was wrong. Hence, root 2 is a irrational number. Okay. Thank you.